Hello and welcome to our channel. Today we will be doing a deep dive into deep learning and all its components part 2. What is the difference between machine learning and deep learning? Deep learning is a specialized form of machine learning. A machine learning workflow starts with relevant features being manually extracted from images. The features are then used to create a model that categorizes the objects in the image. With a deep learning workflow, relevant features are automatically extracted from images. In addition, deep learning performs end-to-end learning, where a network is given raw data and a task to perform, such as classification, and it learns how to do this automatically. Another key difference is deep learning algorithms scale with data, whereas shallow learning converges. Shallow learning refers to machine learning methods that plateau at a certain level of performance when you add more examples and training data to the network. A key advantage of deep learning networks is that they often continue to improve as the size of your data increases. Choosing between machine learning and deep learning. Machine learning offers a variety of techniques and models you can choose based on your application, the size of data you're processing, and the type of problem you want to solve. A successful deep learning application requires a very large amount of data, thousands of images, to train the model, as well as GPUs, or graphics processing units, to rapidly process your data. When choosing between machine learning and deep learning, consider whether you have a high-performance GPU and lots of labeled data. If you don't have either of those things, it may make more sense to use machine learning instead of deep learning. Deep learning is generally more complex, so you'll need at least a few thousand images to get reliable results. Having a high-performance GPU means the model will take less time to analyze all those images. How to create and train deep learning models. The three most common ways people use deep learning to perform object classification are: training from scratch. To train a deep network from scratch, you gather a very large labeled dataset and design a network architecture that will learn the features and model. This is good for new applications, or applications that will have a large number of output categories. This is a less common approach because with a large amount of data and rate of learning, these networks typically take days or weeks to train. Transfer learning. Most deep learning applications use the transfer learning approach, a process that involves fine-tuning a pre-trained model. You start with an existing network, such as AlexNet or GoogleNet, and feed in new data containing previously unknown classes. After making some tweaks to the network, you can now perform a new task, such as categorizing only dogs or cats instead of 1,000 different objects. This also has the advantage of needing much less data, processing thousands of images, rather than millions, so computation time drops to minutes or hours. Transfer learning requires an interface to the internals of the pre-existing network, so it can be surgically modified and enhanced for the new task. MATLAB has tools and functions designed to help you do transfer learning. Feature extraction. A slightly less common, more specialized approach to deep learning is to use the network as a feature extractor. Since all the layers are tasked with learning certain features from images, we can pull these features out of the network at any time during the training process. These features can then be used as input to a machine learning model such as support vector machines, SVM. Deep learning applications. 1. Self-driving cars. Secondly, news aggregation and fraud news detection. Third, natural language processing. Fourth, virtual assistants. Fifth, entertainment. Sixth, visual recognition. Seventh, fraud detection. Eighth, healthcare. Ninth, personalizations. 10th, detecting developmental delay in children. 11th, colorization of black and white images. 12th, adding sounds to silent movies. 13th, automatic machine translation. 14th, automatic handwriting generation. 15th, automatic game playing. 16th, language translations. 17th, pixel restoration. 18th, photo descriptions. 19th, demographic and election predictions. 20th, deep dreaming. Thank you for watching. We hope you enjoyed, and found it informative. Please like and subscribe not to miss out on more.